Okay, our quick look at the calendar for today. We're going to cover 5.3 and 6.1. Good news for some of you, not a single word problem will appear in today's lesson. Today is all about figuring out what kinds of patterns follow when you're trying to mush x's together. And we'll do something called factoring for the first time. So 2 sections today and then 2 sections of homework due tomorrow, Tuesday, tomorrow. And I just want to highlight that, okay, well, first of all, for the first time all semester, we're seeing the entirety of the end of the calendar. We've never actually seen the bottom of this thing projected on the board before. And I want to point out that next class, we're going to cover 1 section and then review. What are we reviewing for? Is exam 3. So 1 week from today, exam 3, partly with a calculator, but mostly not. So that's 1 week from today, and I'll just repeat very briefly some of the stuff I said when I handed back quiz 3. If you aren't happy with your grade on quiz 3, exam 3 is your biggest opportunity to make up for that grade. There is 1 week between now and then. That's a lot of time. You can put in a lot of effort, change things if things aren't going well for you. Take advantage of the Math Studio, free peer tutoring, my office hours, each other. Lots and lots of resources to help you prepare for that. You've got practice exam in the blue, practice exams in the yellow, lots of resources, and then videos of old classes and PDFs and lots of stuff on Moodle, okay? So if you're not happy with how things are going, you got to change something. Can't keep doing the same thing and expect different results. So that's coming up on Thursday. And again, if you do better on the exam than the quiz, then that quiz grade will be completely replaced by the exam grade. Then the following class, we've got 1 more section in this thing called letters, which I will talk to you about then. But then the class after that, which is 2 weeks from today, is this optional makeup or retake. You don't need to come in unless you want to take either exam 2 or exam 3. It's on Thursday the 8th. Yes, Meg? It can't possibly hurt you. I will only replace your exam 2 or 3 grade if you do better on this makeup. Right? So there's nothing to lose by coming in, but if you don't want to come in, then don't come in. It's okay. But you can choose to retake exam 2 or exam 3, not both. I will ask you to pick one of those on the class before this makeup day, okay? All right, so that's that, and then 1 day for reviewing for the final, and then final exam. So it's really coming to an end here. Any questions on the calendar? Okay, and just while it's projected here, our class, this 9:30 class, our final is on Thursday the 15th, which I guess is 3 weeks from today. So 3 weeks from, is that right? Am I doing my counting right? 1 week, 2 weeks, 3 weeks from today is the final exam for us. As usual, you can take the final, you can take the exam with any section, any of the 5 sections that Sandy or I have. There are other choices here for the 20th, and then there are some Monday, Wednesday, Friday choices on the other side of this schedule. And I'll ask you to pick one of those soon enough. Okay, enough of that stuff. Let's jump in on 247 here. And we'll take a look at the objective. We'll go to Meg B. Oh, not quite ready. Eric, the objective? Okay, so let's take a look at number 1. It says fill in the blanks to show why x squared over x to the 6th is really equal to 1 over x to the 4. Okay, same game we played last time. We're trying to figure out what's going on here, so let's just list the x's out. We have x times x upstairs. How many x's downstairs? So write 6x is down there. And then we know we can cancel. Any x upstairs can cancel with an x downstairs. So we're going to cancel both the x's upstairs, and we're going to cancel 2 x's downstairs, right? You're crossing off the same number of them. And then I got to put a placeholder because everything upstairs disappeared. So what number is up there? 1. And how many x's are left over? 4 of them. And so 1 over x to the 4th is our answer. And again, if you take a future algebra class, you're going to see this presented as a rule. What's the rule? What do you do with the powers? Subtract them, right? 6 minus 2 gives you the 4, and that's, okay, yeah, it worked. But this class, I'm not asking you to memorize rules, and I don't want you to apply rules either. I want you to Just write some stuff out, because there are so many ways to think you have the right rule and get it wrong. You can know it's subtraction, but so here are some wrong answers. You can know it's subtraction, and you can say, oh, 6 minus 2 is 4, and the answer is x to the 4. Is that right? No, it's 1 over x to the 4, right? Last class we saw adding the powers together. You can add the 2 and the 6, and you can get x to the 8. Or you can put them on the bottom and get 1 over x to the 8. Neither of them is right, but they're both reasonable things to try to do with those powers. Add them together. You could also divide the powers, right? I see a division, so maybe I should be dividing the 2 and the 6. So maybe I get something like 1/3, or x cubed by taking 6 divided by 2. There are a lot of things that we can do with the numbers 2 and 6. Only one of them is right. And I don't want you to fall into a trap of thinking, oh, there's this nice little shortcut I can apply, and then just get it flat wrong, okay? So write the x's out. Well, let's take a look at number 2. We'll go to Meg now, Meg B. Okay, so let's give this a shot. So we're seeing the word factor for the first time. It's okay if you don't know what this word means, but we're going to take the 12x squared y plus 18x cubed, and we're going to write it in a different way. And so the first way is going to be the kind of short and sweet way. And if you miss any of the details there, that's totally fine. We'll give you the detailed way in a second. So looking at the two terms, I'm just going to kind of put a little squiggly line here over the plus sign, just so I can really separate these two terms from each other. 12x squared y and 18x cubed. What number goes into 12 and 18? 3 goes in, 2 goes in. You want to pick the biggest number that goes in, which is 6, okay? So we're looking for the biggest number that goes in, it's 6. So I'm going to put a 6 right there in the front, because it's the biggest number that goes into 12 and 18. Now in this first term, I have x squared, so I have 2 x's. In the second term, I have x cubed. I want to take out the biggest thing I can that's in both of them. So how many x's can I take out that are in both of them? Is 2. You can't take 3 x's out of this first guy because you don't have 3 x's there to play with. So you take as many as you can, but you got to take out whatever you have, right? The 12 and the 18, you couldn't factor 18 out of both of those. You had to factor something smaller. So we're going to take an x squared out and put it right there. And the only other thing that I see here is there's a y in the first term and no y's in the second term. So I can't pull a y out of both of them because there aren't any y's to play with over there. Then I'm going to put some parentheses. And then that plus sign with the big squiggle through it, I'm going to copy right here. And now comes the hard part. What we're trying to do is fill in the blanks. Now we know that when we have a setup like this, it's a distributive thing, right? Like part of a lobster claw. So what we have to do is fill in these two blanks so that when I take that 6x squared and distribute it back in, I end up right back where I started with. So 6x squared times something is supposed to give me this 12x squared y. So let's underline here in purple. That's going to give me here. So 6 times what will give me the 12? 2. And then I've got x squared times something is supposed to give me x squared. Do I need any more x's in there? Do we need 1? I just need the y. I don't need any more x's in there. If you put another x in there, x squared times x would be x cubed. We only have x squared, so we don't need any x's, but we do need a y, because this 2y times this 6x squared will give me 12x squared y, which is exactly what I want. Let's work on the other piece. I'll put it here, and it's supposed to give us this guy. Yeah, so we need 6 times something to be 18. 3 is the magic thing. Now I have an x squared out in the front, but I need an x cubed when I'm done. So how many x's do I need to stick in here? Just 1. And so if we do this distributing over here, what do we get? 6 times 3 is 18. What about pushing these x's together? Is x cubed, right? And so I'll say, looking at the original, the only operation I can find is addition. I mean, there's some multiplication in there as well, but this is basically an addition problem to start with, right? But what's the main operation here? It's multiplication. It's 6x squared times something. The something happens to have addition in it, but this is now a multiplication. And so when you see the word factor, it says up here, it means factor means write as a product, and that's what we did. It used to be a sum in addition, and it's now a product. Or undistribute, because it's the opposite of distributing. It's like undistributing, okay? And actually the word factor is not a new word for you. Like if I said factor the number 21, how could you factor 21? Right, 7 times 3 is 21. So you took a number and you turned it into what operation? Multiplication. That's what factor meant for numbers, like way back when you learned about taking 21 and writing it as 7 times 3. It's the same word and the same meaning. You take the thing, you turn it into multiplication. Now, it's not clear at this stage, and it won't be clear at any point this semester, why a multiplication version is better than an addition version. I have to take my word for it, and that will become clear next semester if you take another algebra class. But this semester, we just want to make sure we get this technique. Okay, so that's the just by looking method. So let's do another method. Here's the write it all out method. Don't feel obligated to do this, but if it's helpful to you, then do it. Okay, so we're going to look at that 12 and the 18, and we're going to ask the same question as before. What's the biggest number that goes into both? 6. So I'm going to take that 12 right now, and I'm going to write it as 6 times something, 6 times 2 in this case. And then when I see this x squared, I'm going to write it out, x times x. And then the other thing here is a y. And then there's a plus. And then we're playing the same game. 18 is really 6 times 3. And then instead of x cubed, what are we writing? 3x's. So far, so good? Okay, I'm going to put the big squiggle through the plus sign again to really separate my two terms from each other. And then what I'm going to do is circle everything that's the same in front of the red line as after the red line. So what do you see that's exactly the same before the red line as after? There's a 6. So I'm circling both of those 6's. And then 2 x's. I'll circle them both in one circle. You guys buy it? That's what's the same in both. There's a 6, and an x, and another x. And I can't circle the 2 because there's no 2 over there, and I can't circle the 3 because there's no 3 in the front, and I can't circle the y because there's no y over at the end, and I can't circle that extra x because I don't have any more left over here. Okay, so we understand this idea of circling what's the same. And then whatever's the same can get pulled into the front, and so this is the factoring stage. So both of those 6's come to the front and become a single 6. The x squared there and the x squared there both come to the front and become a single x squared. So just put one copy of whatever you circled. And then when it comes to writing in the parentheses, this is where I think writing it all out is a nice thing, is that what goes in the parentheses is just the stuff you didn't circle. So what didn't we circle in the first set before the red? 2 and a y, right? The 6xx is already in the front, but the 2 and the y haven't appeared yet, so we put the 2 and the y. That red thing is hiding a plus sign. And then what isn't circled after the red thing? 3 and an x. And again, the 6x squared is already in the front, so we don't need to put it there. It's been pulled out. And what's left over is a 3x. And you can compare and see that what we got there by kind of writing it out is the same as, or by not really writing much out, is the same as we got when we wrote it all out. Questions on that? It's not a hard process, but it is a process that's foreign until you practice with it enough. So let's practice. On the next page, classwork starts there. keep on going until I say stop, and we'll come back together in a little while. All right, so it takes a few pages to get to 262, which is because we just jumped over the practice exam for exam 3, which means that the stuff that we're about to do is not on exam 3, right? So we just finished the last sections of stuff that are on exam 3. This coming section will be on the final, but not on this next exam, all right? So let's jump up here to the objective, and we'll go to Geneva, please. Monomial. Okay, so let's take a look at this guy. X cubed, all raised to the 4th power. Now, again, there are rules that you might start to learn by doing a lot of practice here, but let's just start making some guesses before we actually figure out what the right answer is. There's different things you can do with the 3 and the 4. What could you do with the 3 and the 4? You could multiply them. 3 times 4 is 12, right? That's one thing you could do with 3 and 4. What else could we do? 4x to the 12 because of the 4 in the front. Good. What else could we do? Yes, we are going to do that to get to the right answer. But I just want to convince you that there are plenty of things that you can do that seem reasonable that aren't right. So we've multiplied the 3 and the 4. What else could we do with the 3 and the 4? We could add them. X to the 7, right? We could. We could subtract them. We subtracted powers earlier today. So subtracting those powers gets 1, right? 4 minus 3. Here's something else you could do. How much is 3 raised to the 4th power? Because that's kind of what that looks like, right? 3 to the 4th? Yeah, 3 times 3 times 3 times 3 is 27 is the first three threes, times 3. Easier is to do 9 times 9. 81. Reasonable, right? It looks like 3 to the 4th. 3 to the 4th is 81, so x to the 81. There are a lot of answers up here. Only one of them is right. So let's figure out which one it is. So the first thing we're going to do, we see x cubed raised to the 4th power. Here's what I'm going to do. I'm going to say, if I have something raised to the 4th power, it really means write it 4 times. You guys buy that? That's just writing out what a 4th power means. It means you copy the thing in the parentheses 4 times. Okay, but now I've got a bunch of x cubes, and we've been writing out a lot of those things, so let's continue to do so. So the first x cubed becomes xxx, and then the next one becomes xxx. So write them all out. And then you look at them and you say, okay, what do we really have? We have 12 of them. So what's the shorthand way to write that? X to the 12. So this is our answer. Okay, so what's the shortcut? What do you do with the powers? To get 12, we got to multiply the 3 and the 4, right? Yes, but this is a perfect reason for not trying to implement any shortcut because it's so easy to get it wrong. So just write them out. Let's take a look at number 2. Number 2 looks more complicated. I would strongly encourage you not to think about any shortcuts, not to try to apply any rules, but just list things out, take your time. You will have time on the test and the final to take your time. So first thing I see is a 3w. I can't do anything with that at the moment, but it's tempting. It's tempting to do 3 times -2. But that -2 is in parentheses. And if I see something cubed, I'm going to write it 3 times. In those parentheses, everything was cubed. So everything in the parentheses got written 3 times. Do we see it? In the front was a 3w. There was no reason to write that any more than once because it wasn't squared or cubed. It was just solitary 3w. But the stuff in the parentheses was cubed. So we just write it 3 times. What's the next symbol after the stuff that was cubed? minus, and then the w to the fifth. There's nothing to do with it at the moment. It is tempting to try to take the w to the fifth and mush it with the w in the parentheses. Don't, not yet. Meg. You don't. I mean, you can put them if you want to, but you don't need them. Parentheses mean multiplication, and that's, I just put a dot. Yes, because there's an invisible dot right there. I don't know if you saw that there. Okay, what's the next thing I see is a negative 4w squared. Don't do a shortcut. What are we writing? Negative 4w and negative 4w. Okay, just write it out. See something squared, write it twice. Cubed, write it 3 times. Okay, now we're going to head to our final answer. So I'm going to put my squiggly line to really separate. There's really only, so there's a lot of multiplication in here, but there's only one addition or subtraction. Do you see where the single subtraction is? Because there's a ton of minus signs up there, but there's only one subtraction sign. It's right in front of the w to the 5. This guy right here. You see it? All the other things that look like minus signs are really negative symbols. They're not subtraction. But that one guy right there is the subtraction. And it's important to recognize that because that means that this stuff is entirely different from this stuff. And so I'm going to try to simplify the first stuff that's underlined in green by just bringing together all the numbers. I'll put them in the front and then collecting the w's. I'll think of them at the end. So I see a 3 times negative 2 times negative 2 times negative 2. Very carefully do that calculation. So in my mind, we're just multiplying them all together because you can shuffle around multiplication and it doesn't change anything, right? 3 times 4 is the same as 4 times 3, yes? Yes? 3 times 4 is the same as 4 times 3? Yes? Right. So I can multiply these guys in any order I want. And so I'm going to choose to shuffle all the numbers to the front in my mind. So what do we have here? Negative 6 times, so it's negative 24. So negative 24 is there. And then the other things that are still left over, underlined here in green, are all the w's. I'm not going to do a shortcut, but I'm also not going to write them all out. I'm going to do kind of a combination. I'm going to envision seeing them all written out. So I have a single w here, then I have ww. So how many w's do we have so far? 3, and then you have ww, which is 5, and then ww is 7. And so what are we writing? W to the 7. See it? Feel free to write all the w's out if you wish. But if you can just imagine them, that's okay too. So you had a single w, and then another couple of w's, and another couple of w's, and another couple of w's, and counting them all up, 7 altogether. What's the next symbol after the underlined green? Is a subtraction. It's this minus. And then we're going to look at the numbers. We're going to shuffle them to the front in our mind. So looking over at this part right here, that minus 4 times that minus 4 becomes positive 16, which is there. W to the 7 is correct. And so you look at the w's and you say, okay, I imagine 5 w's laid out in front of me, and then another one, and then another one. And so there's 7 w's altogether. And then normally this would be the final answer, but if you can combine, then you should. This is a subtraction problem, and subtraction for me is like apples and oranges. So here I have negative 24 apples. Are those apples over there or those oranges? Apples. Those are apples because it's exactly the same W7 in both. Negative 40 is good. It's very easy to put the wrong power on the W. You had negative 24 apples and then minus 16 apples. So you have negative 40 what? Apples. W to the 7. Doesn't change. W to the 14 or W to the 49. It's just apples. And all we were doing was counting them. Geneva. Okay. So lots of practice with this. Again, do not go for any shortcuts. Just write things out. Shortcuts will come with practice. But Applying the wrong shortcut gives you nothing good. Actually heads you in the opposite direction of where you want to go. Okay, classwork is here. Raise a flag if I can help. See how far we can get.